So welcome to lesson 1.5, where we're going to take a look at graphing linear systems. Remember that a linear system is a set of two or more linear equations on the same set of axes. So linear systems can be solved graphically or algebraically, but in this lesson, we're only going to focus on graphing linear systems to find the point of intersection. And that point of intersection is the solution to the system because it satisfies both equations that are given. So let's take a look at A. In A, we are given one equation that is y equals x plus 1, and the other one is y equals negative 2x plus 4. So here, I'm hoping you notice that they are both in y equals mx plus b form. And so that is how we are going to graph them. So for the first one, I'll say b1 is equal to 1, and the slope of the first one is equal to 1. So I'm just using the notation of a subscript of 1 just to denote the slope and the intercept of each of the separate equations. So for the second one, b2 is 4, and m2 here is negative 2. So now that we have the intercepts and the slopes, let's go to our graph and we'll plot those. So for the first one, we have an intercept of 1. So there's 1 point. And then we have a slope of 1. So I'm going to go up and over 1, up and over 1. And I'm just going to fill in a couple more of these points so that when I draw the line, okay. So there is the equation of our first one. Then we try to graph the second one. Our intercept, y-intercept starts at 4, and our slope is negative 2. So we're going to come down 2 over 1, down 2 over 1, and we can already see where that point of intersection is between the two equations. We'll go ahead and draw this line in. Wow, that's not a very good line, but it crosses. And then I'll identify the point of intersection. That's the solution to my system. And if I go back over here, my point of intersection is 1, 2. Double check. Yes, it's 1, 2. All right. Take a look at B. When you look at B, you can see that these two equations are not in slope-intercept form. So I'm actually just going to split this in half, and I'm going to find the x and y intercepts for each of them and graph them that way. So to find the x-intercept of the first one, I'm going to set y equal to 0, and I'll have 3x plus 2 times 0 equals 6. 3x equals 6. So x equals 2. And I'll call that x1, the x-intercept of the first equation. Then if I want to find the y-intercept, I set x equal to 0. And I'll have 3 times 0 plus 2y equals 6. So 2y equals 6. And y1 is going to be equal to 3. So I have my x-intercept of the first equation and my y-intercept of the first equation. I'm going to do the same thing for my second equation. And if I want to find the x-intercept, again, y is equal to 0. And so I have negative x plus 2 times 0 equals negative 6. That leaves me with negative x is equal to negative 6. And so x, in this case, I'll write 2, is equal to positive 6. So that's the x-intercept of the second equation. Then if I want to find the y-intercept, I'm going to set x equal to 0. So I'll have negative 0 plus 2y equals negative 6. Simplifying gives me 2y equals negative 6. Simplifying again gives me y2 is -3. So with these intercepts, let's go ahead and graph both of these two equations on the axes. And so for the first equation, we had an x-intercept of 2, and we had a y-intercept of 3. And so I'm going to draw in my line between these points. All right. And then I will graph the second line, which the x-intercept was 6. And the y-intercept, sorry, plotted that on the wrong point. Sorry, the x-intercept was 6. And the y-intercept was -3. So I have those 2 points. All right. So we see we have an intercept here. It's a little off just because of my graphing skills. But here I would say that that intercept is probably maybe 3, -1/2. So how can we check this? We can go back and plug those two values. I'm sorry, I said 1.5, and I wrote something else. -1.5. All right, so to check if we're right, even though because we're estimating a little bit this point of intersection, we can go back and plug these points or these coordinates into one of the equations and just check to see if we're correct. So let's go ahead and do that. We will use, let's see, the easier of the equations, I would say, is -x plus 2y equals -6. So let's do -x plus 2y equals -6. And let's plug in the coordinates x and y from our point of intersection. -3 plus 2 times 1.5, -1.5 equals -6. So -3 minus 3 equals -6. And it looks like this checks out. So I'm going to go ahead and say that this point of intersection is the solution to this system. Moving on. What's the point of intersection between these two lines? Well, recall that the general equation for a vertical line is x equals a, and the general equation for a horizontal line is x equals b. So what we have here is one horizontal line and one vertical line. So let's go ahead and graph them. So x equals -1 will be a vertical line that passes through -1 on the x-axis. Y equals b is going to be a horizontal line that passes through 3. uh, and we can see that the point of intersection here just corresponds to the values of each of those lines. Now let's take a look at a problem, a word problem that we set up that is a system of equations. And again, we're going to try and solve these by graphing. So the situation is Miss J buys 4 muffins and 2 coffees for $16. Miss V buys 2 muffins and 4 coffees for $14. So we need to create let statements for the two situations. So let's let M represent muffins, and C represent coffee. So if we were to come up with an equation for Ms. J, she buys 4 muffins, so 4M, and she buys 2 coffees, 2C, and she spends a total of $16. So that's our first equation. Now for Miss V buys 2 muffins and 4 coffees, and she spends $14. So we've built 2 equations based off of our information in the word problem, and now we want to graph them and see where they intersect. Both of these look like they are in a format that we would use the intercepts. So let's go ahead and do that. And I'm going to split my space here into 2. So for my first equation, which is 4M plus 2C equals 16, let's find the M-intercept by setting C equal to 0. So 4M plus 2 times 0 equals 16. 4M equals 16 and M equals 4. Next, we want to find the C-intercept. So we have M equal to 0. So we have 4 times 0 plus 2C equals 16. So 2C equals 16, and C is then equal to 8. All right, and those are my intercepts for my first equation. Well, let's find the intercepts for the second equation. 2M plus 4C equals 14. So to find the M-intercept, again, let's let C equals 0, and 2M plus 4 times 0 equals 14. So 2M equals 14. And so M equals 7. Let's find the C-intercept. That means M is going to equal 0. So for my equation, 2 times 0 plus 4C equals 14. And we have 4C equals 14. If we do the division here, it comes out to 3.5. So sometimes it's hard to deal with decimals while we're graphing, but this is just 3.5. We should be able to manage. All right, let's go to our graph. And we'll graph the intercepts of our first equation, which let's name this axis M and this vertical axis C. So for our first equation, the M-intercept is at 4, and the C-intercept is at 6. So there is our line for the first equation. The next one, we have an intercept, M-intercept of 7, and a C-intercept of 3.5. So I'll put that about there. Then we'll connect those two. All right. All right. And again, just due to my drawing, if I had a ruler, which I hope you guys are working with the ruler, it'll be a lot easier. I'm going to estimate these and this intercept to be 3 and 2. So let's go back to the problem and see, well, what does 3 and 2 mean? Well, remember 3 was the muffins. So that means that each muffin costs $3, and each coffee costs $2. All right, so there we go with this lesson. Hopefully, again, you've come back to remembering how to solve a linear system by graphing, which basically means drawing 2 points on the same graph and finding the point of intersection between them. When we're dealing with word problems, make sure you can relate the point of intersection back to the context of the problem, like we did with the muffins and the coffee. So go back to our Google Classroom. There's a worksheet for you to do, but I also wanted to mention that for this lesson, you also have your first small assessment, just a little quiz. It's on an online platform called Quilgo. And Quilgo is a program that'll help me keep an eye on how many tabs you're opening, how many times you get up. So it works as a proctor for the test. And it assigns you a specific number of time to complete the test. So we'll try that. We'll see how it goes. If you have any questions, reach out, and we'll see you in the next lesson.